So today we're going to talk about the last transformation. So again, we have our order. Order is very important when it comes to transformations, HSRV. So we've done H, horizontal translations, moving left and right. S is for stretches and shrinks, that's getting taller or shorter. Reflections, flipping over the X or Y axis, and now we're going on to V, which stands for vertical translations. This is moving up or down. So vertical translations are similar to horizontal translations in that it is addition and subtraction, but with horizontal translations, that addition or subtraction happened inside the parentheses. With vertical translations, the addition or subtraction happens outside of the parentheses. So addition or subtraction outside of the parentheses. And then it's kind of the opposite from horizontal translations. If you remember with the horizontal ones, when we add on the inside for horizontal, we go to the left. When we subtract, we go to the right. With vertical, it makes more sense. When you add, you go up. When you subtract, you go down. So for adding, we go up. For subtracting, we go down. Okay, so what this would look like for each of our parent functions. Vertical translation up, again, will be adding. And so this addition just has to be happening on the outside of the parentheses. So we can have like f of x equals x plus 2 or y equals x plus 2. Again, if there's no parentheses grouping the x and that addition together, then it's considered on the outside. In order for it to be inside, there'd have to be parentheses around them both. So this would go up 2. For quadratic, to vertically translate a quadratic up, again, the addition would just happen outside, so it's not going to be in that squared with the x. So I'll have y equals x squared plus 2, or sometimes the parentheses won't be there, but since that plus 2 is not happening inside that squared, it would be considered on the outside, so we would go up 2 for here as well. Square root, the addition would just be happening outside of the square root, so it's not underneath the square root with the x. So in this situation, this is where you have to be very careful with your square root symbol. You need to make sure that the square root symbol stops, and then you have plus 2. If you're rushing, sometimes the symbol can get longer and it can look like it's kind of over the 2. We want to make sure that it's clearly stopping, and then we're adding 2 on the outside. Sometimes to help make that a little more clear, you can bring your square root symbol down a little bit around the end. So it kind of denotes here is the end of that square root symbol. But you don't have to do that, just make sure it's clear that the symbol stops and then you're adding or subtracting on the outside. And again, sometimes there'll be parentheses inside the square root, but not always. So as long as the plus 2 is happening not underneath the square root symbol, that would be on the outside. And then absolute value is a little more obvious. It's just not in between those absolute value bars. So absolute value of x and then plus 2 on the outside. Again, sometimes there'll be parentheses inside the absolute value bar. Sometimes there won't be. But if that plus 2 is happening on the outside, you have vertical translation. Okay, so adding, we're moving up. Subtracting, we will be moving down. So down is a subtraction. The subtraction will be happening in the same places as the addition. It'll just be subtraction instead of addition. So we can have f of x equals x minus 2 in parentheses, or just x minus 2 with no parentheses grouping them together for a linear. For quadratic, we'd have x squared and then the minus 2 happening on the outside. Sometimes there'll be parentheses around the x squared, sometimes there won't. But if that subtraction is happening outside of the squared, it's not being squared, it would be vertical. Then our square root symbol. Again, making sure it has a clear stopping point. You don't have to do the little down thing, but just make sure square root stops. And then you're adding, oh, this should be subtraction, sorry. So minus 2. I was just copying the other one. Minus 2. And then absolute value is just not inside those absolute value bars. Okay. So that's the last. Now we know all of our transformations, H, S, R, V. So when we start doing problems, you are going to have to be able to identify all 4 of those transformations and tell me what is happening to the graph. So you need to be able to pick out each of those individually from an equation. So example 1, we're just going to practice just identifying the vertical translation, so what we just talked about. So again, vertical translations is when we are adding or subtracting outside of the parentheses, or outside of the square root, or outside of the squared. So in the first example there's a lot of stuff going on in that quadratic because it's a squared. It's a quadratic. But what number in this equation here is representing a vertical translation? Yes, the +6 at the end, because it's addition that's happening on the outside. And when we add, we go up. Yeah.
So what happens if there's like no parentheses? How do you do the parentheses?
So if there's, like for the quadratic, there would have to be parentheses around the horizontal stuff. It'd have to be grouping it together in the squared. With the linear, same thing. There would have to be parentheses grouping any horizontal stuff together. With square root and absolute value is a little more obvious. It's just not happening underneath that symbol. So if the addition's happening outside of the square root symbol or outside of the absolute value symbol, it's vertical. If it's happening inside those symbols with the x, then that'd be the horizontal. So like letter B, what number here is representing a vertical translation? The -5, because that is subtraction happening on the outside. And since it's subtraction, we'll be going down 5. And what type of function is this? Square root. Because of the square root symbol. All right. Example 2, identify and graph the parent function f of x equals square root of x. So what is the name of this parent function? Square root. When you read it, it kind of gives it away because it has a square root symbol. This is the square root parent function. So now we want to graph it, so you can use your calculator. Remember, to get the square root symbol, you hit the second button and then x squared. The x squared key that gives you that square root symbol, and then hit the x button, xt theta n, to get your x. Plug that into y equals and hit graph. You can see what it looks like, and then look at your table to get some specific points. And sketch your graph on your paper, and hit graph one more time in your calculator to make sure that what's on your paper matches what's on your calculator. Okay, the calculator gives you the answers. Make sure you're using it. Okay, so now letter B, we want to write the equation for a function that is translated down 2 units. So we want to go down 2. That means we're going to subtract 2 on the outside. So remember, when we are writing functions, we have to make sure that our type of function is matches the parent function. So we had a square root for our parent function, so we have to make sure that our new function has a square root as well. And all we're going to do is subtract 2 on the outside. So we'd have square root of x, and then outside of the square root symbol, we would subtract 2. So when you type this in your calculator, so you get the second x squared to get your square root symbol, then depending on what your calculator does, if it comes up with the square root symbol in a parenthesis, you would type your x and then close the parentheses before you subtract 2. Or if it just shows up with the square root symbol and everything shows up underneath that line, you would type your x, and then you have to hit the right arrow to scooch out of the square root symbol, and then subtract 2 on the outside. So you just have to make sure that your subtraction is happening outside of the square root and not inside the square root. So you guys should all be practicing typing this into your calculator. Parentheses are important. Your calculator doesn't know what's on your paper, you need to tell it. So you need to practice using parentheses correctly and typing this into your calculator correctly. So when you do that, when you look at your graph and you look at your table to get some points, you should see that your graph does move down 2. If you graph it and you see that your graph didn't move down 2, then something happened, because we said we were trying to make an equation that would move our graph down 2. So always use your graph to double check. Okay, and move down, which is what we wanted to do. Always check, make sure it makes sense. Yeah.
So you put in your calculator, you put it in the line?
Yeah, y equals. Yep. Yeah, that's good.
And
Yeah, yours, we'll just hit zoom and then 6. That's good. Yeah, that takes it back to the normal one. Yep. All right. Next example. What is the name of this parent function? Absolute value, because we have these absolute value bars. You guys have to know these names. Absolute value. So to graph it, go to y equals. Remember to get these absolute value bars. You go to the math. Hit the math button. Go over to the NUM menu. And then it's the first option, ABS. So anything in those bars or in those parentheses would be in the absolute value. So you type your x. Then look at your graph, look at your table to get some points, and connect your dots. So once we have our parent function graphed, if we look at our transformed function here, we have f of x equals the absolute value of x plus 1. So we have addition that's happening on the outside, which means this is a vertical translation. So up or down are the options, and we're adding 1, which means we'll be going up. So up 1. So to graph it, again, you have to be very careful with parentheses. So it depends on what your calculator shows you. If your calculator just has the ABS with a parenthesis show up when you hit the ABS button in that menu, then you would just type your x, then close the parentheses before you add 1. Or if it shows up with the actual bars, you would type your x in the middle, then hit the right arrow to get outside of the bars before you add 1. So just make sure that the equation that's in your calculator matches the one that's on your paper. And when you graph it, you should see that your graph does indeed move up 1. If it's not moving up 1, then something happened, and you should double check either the equation that you wrote or how you typed it into your calculator. There are a lot of opportunities to check your work here to see if you're doing everything correctly, so make sure you're doing that. Okay, so now we know all of the transformations, H, S, R, V, so we're going to go through and summarize it in a table so all of the information is in one spot. So H, this is horizontal translations. Where we move left or right. And the way we can identify horizontal translations in an equation is when we are adding or subtracting inside the parentheses. Okay, so for example, we could have like x plus 2 in parentheses squared. Those parentheses are grouping that x plus 2 together. That would be considered on the inside. Or y equals square root of x plus 2. That plus 2 is happening underneath the square root. That would be considered on the inside. If that addition or subtraction is happening in the same spot where that x is, right next to the x, that's going to be a horizontal translation. Okay, then S stands for stretches and shrinks, vertical stretches and shrinks. Vertical stretch or shrink. It's where our graph gets taller or shorter. And how we identify stretches and shrinks in an equation is when we have multiplication by a positive number happening on the outside. Of a positive number outside the parentheses. Again, it's important that you deal with only positive stuff with stretches and shrinks, because remember the negatives are the reflections, they're their own thing. So stretches and shrinks will always be positive numbers. So outside of the parentheses just means there's no parentheses grouping it together inside the function. So being squared or square root or absolute value. So if we had like 1/2 x squared, there's no parentheses grouping the 1/2 and the x together. So that 1/2 is not being squared. It would be on the outside. Or if we had y equals 2 square root of x. That 2 is outside of the square root symbol. And when we multiply by a number less than 1, that's a shrink. When we multiply by a number greater than 1, that's a stretch. I'll read it right there. For a horizontal translation, if we add on the inside, so remember for adding on the inside, that means we move left. And I'll change that second one to subtraction. When we subtract on the inside, that's when we move right. So remember, horizontal stuff is kind of opposite of what you would think. Okay, and then R is for reflections, where we flip over either the X or Y axis. And how we identify reflections in an equation is by negative signs. Just a negative sign. The number, if it's in front of a number, that number would be with the stretches and shrinks. The reflection is just the negative sign. And we can have negative signs inside or outside. So we had a negative on the outside. that is when we reflect over the x-axis. And if we have a negative on the inside, we reflect over the y. Okay, so again, parentheses are important. In order for it to be on the inside, there has to be something grouping it together with the x, whether it be parentheses or just a square root symbol or an absolute value symbol. Something has to be grouping the inside stuff together. Okay, and then our last one, vertical translation is what we just did today. So moving up or down. And this is when we have addition or subtraction on the outside. So adding or subtracting on the outside of the parentheses. And vertical is kind of straightforward. If you add, you go up. If you subtract, you go down. Okay, so adding on the outside moves your function up. Subtracting on the outside moves your function down. Okay, so now that we have all of this stuff together, we again have to be able to pick out each of these individual transformations when there's a lot of stuff happening at once in an equation. So example 4, we're just going to focus on just picking out one specific transformation at a time. So letter A, first we need to identify what is the parent function of this equation here. Linear, because there's no squared, it's not quadratic, there's no square root symbol, so it's not square root, and there's no absolute value bar, so it's not linear. It's just a plain old x with nothing fancy happening, so this is a linear function. And now we just want to identify what is the vertical stretch or shrink. What number in this equation is representing a stretch or shrink? Nope, that's the vertical translation. We want the stretch or shrink. This is what we did the other day, 2 days ago. The 3 over 2, not the negative. Negative is a reflection, just the 3 over 2. So since 3 over 2 is greater than 1, this would be a vertical stretch by 3 over 2. Okay, so you got to be careful, even though it is a fraction, that fraction is bigger than 1, which would make it a stretch. Okay, letter B, what is the parent function of this one? Square root, because you have a square root symbol. And now we just want to identify the horizontal translation. So this is the first thing that we learned on Monday. So what number is representing a horizontal translation? So we just set it up in the table, right? Horizontal translation is adding or subtracting on the inside. So go ahead, Angelina. Left 8, yeah, because of that plus 8 that's happening on the inside of the square root. So since we're adding, we move to the left. Okay, letter C, what is the parent function of this one? Absolute value, because of these absolute value bars. And now we just want to identify the reflection. What part of that equation is a reflection? The negative sign, yeah. So remember, it's a negative sign, not a subtraction sign. So it's the negative sign that's out in front. Even though it is a minus 3, that's subtraction. It's not a negative. And then subtracting 2. Yeah.
You can move the x and the y axis and then
It can, yeah, but it would have to, again, be a negative in front of the x, not subtraction. So, yeah. Yep, yeah, it is possible to flip over both the x and the x and y axis in the same equation. But this one just has one negative, and it's on the outside, which means we will reflect over the x-axis. Okay, so when we're doing these, you have to go one thing at a time. Find your h, then s, then r, then v. All right, so we're going to use our calculator to help us. You want to identify the parent function name and equation, describe the transformations, and graph both the parent and transformed function. So, example A, what is the parent function? Absolute value. What is the equation of the parent function for absolute value? Parent functions, remember, are the most boring ones. So it's just absolute value of x with no addition or multiplication or anything going on. So y equals absolute value of x is the parent function equation. Okay, now we need to describe the transformation. So remember, h, s, r, v, we have to go in this order. So let's just identify what we have going on in our equation first, and then we can write it down in words. So h, horizontal translations, that's adding or subtracting inside the parentheses. Do we have an h going on? Yes, we have a +3. That's our h. Okay, what about an s? Do we have any s's? Yes, we have a 2 on the outside. Again, it's just the 2, not the negative. That negative is a reflection, which is our next one. And then our last one is the vertical translation, which is our +2 on the outside. Okay, so now we just go through HSRV order, and we list our transformations that are happening. So for H, we are adding 3 on the inside, which means we would move left 3. Then for S, that's a 2 that we're multiplying by, which is bigger than 1, so it'd be a vertical stretch by 2. Then R is the negative sign, which is on the outside, so we would reflect over the X. And then finally for V, the vertical, we're adding 2 on the outside. Adding means we will go up 2. All right, so to graph it, we want to graph both the parent and the transformed function. So you can graph them both together in your calculator. Just put your parent function in y1, then your transformed one in y2. So your parent function, we've graphed this many times before. It's just the v starts at the origin. But for the transformed function, again, when you plug it into your calculator, you need to be very careful with the parentheses, or make sure you get out of the absolute value when you're done. So you would type your -2, and then math NUM to go to your ABS. X plus 3, close the parentheses, and then add 2. Or if you just have the bars that show up on your calculator, just make sure you hit the right arrow to get out of your bars before you add 2. Make sure the adding of 2 is happening outside of the square root. So you should all be practicing typing this in your calculator, please. You should hear buttons clicking as you type it into your calculator. You need to practice this. So just looking at the transform function, and it can be helpful again to graph them both on your calculator at the same time, but you should always go back and just see if it did what you said it should do. So our graph did move to the left 3, which is good. It did stretch, it's skinnier, it's getting taller quicker. And then it did flip over the x-axis, and it did move up 2. So it's always good to double check that what you have graphed matches what you said should actually happen. Okay, let's not worry about B for right now. Let's go on to example 6. So writing the equations, again, the most important part is making sure that it matches your parent function. So we have y equals x squared is our parent function. What is the name of that parent function? Quadratic. So we got to make sure that in our new function that we're writing, we have to have an x squared. Okay, you can leave yourself some space. You can add in the other transformations, but make sure you have that x squared happening. So now, I'll just go one transformation at a time. So we want to translate right 3 units. That means we're going to minus 3 inside or outside? Inside. So inside those parentheses with the x, we'll have a minus 3. Okay, then we want to vertically stretch by 2 units. That means we're going to multiply by 2 on the outside. So we'll have a 2 outside of our parentheses there being multiplied. Then we want to reflect over the x-axis, which means we'll have a negative sign on the outside. So out in front of your 2. And then translate down 2 units. It means we would subtract 2 on the outside. Okay, you don't have to write it like I'm writing it next to every little thing. You don't have to do that. I'm just doing it so you can see where all these numbers are coming from. If it helps you, by all means, but I know it can get a little messy when you start doing all that writing, so just do whatever works for you. The main thing is that you have this correct final equation here. All right, for the linear function, what's the parent function of a linear? The most boring linear function you can think of. What? Yeah, you can do it in parentheses or just y equals x for the parent function, but then yes, when we are doing our transformed one, we got to have parentheses so that we're able to group the stuff together that we have to group. But there's no squared, no square root, no absolute value. It's just a linear, just an x. Then we want to translate left 2. So we're going to add 2 inside the parentheses. So plus 2 inside. We want to vertically shrink by 2. When we shrink, remember it has to be a number that's less than 1. So multiply by 1/2 on the outside. And then reflect over the x-axis. Should be a negative on the outside. So out in front of your 1/2. All right. Can you guys try C and D? And then don't worry about the self-assessment today. So just try C and D, and then we'll go over those. Okay, so letter C. The parent function was a square root, so you had to make sure you had a y equals and then a square root of x to start with, and then you can add in all the other stuff. So a vertical shrink by 4, it's a shrink, so it has to be a number less than 1, so 1/4 being multiplied on the outside. Reflect over the x-axis is a negative on the outside, and reflect over the y-axis is a negative on the inside. And then translate up 4 units means we would add 4 outside of the square root symbol. Make sure that that's very obvious that that plus 4 is not underneath the square root. Any questions on C? Okay, then letter D, we have our absolute value function, so those vertical bars. So y equals absolute value of x. Leave some space around it so you can add in your stuff. Vertical stretch by 2 means we multiply by 2 on the outside. Reflect over the y-axis means a negative on the inside. And translate down 3 would be as minus 3 on the outside. Any questions?